Warm good evening to all. I'm Karthik, Assistant Professor, Mechanical Engineering Department from SMS Corporate Technology. In this year, we are seeing the lecture series about iron carbon phase diagram. Previously, we have seen about cumulative for solid solution, copper nickel phase diagram, which is the basic phase diagram, and we have seen about ferrite, austenite, cementite, and we also seen about allotropy of iron. In addition to that, in this video we are going to see yet another single phase, double phase, which is formed primarily with the help of ferrite and cementite, and this component, which is called as pearlite, is one of the major microstructure which is formed in most of the steel and cast iron. So this pearlite occurs at both cast iron range and in plain carbon steel. So this pearlite is a microstructure commonly found in steels and cast irons. It is composed of alternative layers of ferrite, which is soft and ductile phase, and cementite, which is hard and brittle phase. This formation of, as we have already seen ferrite and cementite in a separate video, the formation of pearlite occurs during the cooling of austenite, which is a high temperature phase of iron and carbon. When steel or cast iron is slowly cooled from a temperature above the eutectoid temperature, which is about 727 degrees Celsius, or in Fahrenheit we can say is 1341 degree for a plain carbon steel, the carbon atoms in this austenite segregates and combine to form cementite, while the remaining ions form ferrite. So this process results in distinct lamellar structure of pearlite, where the layers of ferrite and cementite are altered, which looks like our thumb impression. This pearlite provides the balance of strength and ductility to a material, and makes it suitable for many engineering applications. As I already said, this occurs in both. This microstructure is formed both in cast iron and steel. So the property of this pearlite can be influenced by many factors. The factors namely cooling rate, alloy composition, and heat treatment. So this pearlite has a combination of both strength and ductility for a material, so that it can be used in many industrial applications. In iron carbon phase diagram, the pearlite occupies a region as an eutectoid region. The region is located at a specific composition of around 0.76% by weight at a eutectoid temperature of approximately 727 degrees Celsius, or in Fahrenheit, as I already said, it is 1341. In composition, can say it is an alternative layer of ferrite and cementite, or the cementite is otherwise known as iron carbide, Fe3C. And when we take this microstructure into the consideration, pearlite has a lamellar microstructure with thin layers of ferrite and cementite alternating. This microstructure is responsible for many unique features, unique mechanical properties for a metal. When hardness comes into the picture, pearlite is relatively hard compared to other microstructures like ferrite. This hardness arises from the presence of cementite, which is hard and brittle phase. However, it is not as hard as martensite, but in another phase formed during the rapid cooling. We will see the martensite in the forthcoming videos. And when we take strength and ductility into the picture, pearlite offers a balance between strength and ductility. It is stronger and harder than ferrite, but not as stronger as martensite. Its ductility is higher than that of martensite, making it more suitable for certain applications where toughness and formability are desired. The pearlite forms during the eutectoid reaction. It's a type of invariant reactions which you will see in the upcoming videos, which occurs when austenite at a high temperature phase of iron carbon alloy is cooled below the eutectoid temperature. As a steel or iron cools, the carbon atom precipitates out of the solid solution to form a layer of cementite, while the remaining iron forms a layer of ferrite. So understanding these properties of pearlite in the iron carbon phase diagram is essential for designing and creating new engineering materials with the specific mechanical properties tailored to for the various applications. This Pearlite is the phase which have so we have both properties of ductility and strength. And that's all for today. Thank you and have a great day.